Woo-hoo! This is the final video that I have to record for the 2020-2021 remote hybrid pandemic school year. All right, let's get to it. Let's take it to the limit, of course. Here we go. So we're going to find limits analytically, mostly algebraically in this video, but we will use our calculator a little bit too. So first off, we've already done it graphically, we've done it with tables, and now we have a third way here. So direct substitution is our first option. Okay, if you can just plug a number in, awesome, dope. Otherwise, there are times where you're going to end up getting the indeterminate. You'll get a 0 over 0. So in that case, we're going to want to do a little bit of factoring, canceling, simplifying, right? And then we'll try some direct substitution again. So let's just start with those first two steps before we get ahead of ourselves, okay? So direct substitution, if I take a look at this one here, the first one, problem number 1, the limit of x squared plus 2x minus 4 as x approaches negative 1. Well, if I just plug in negative 1, let's see what we've got here. So negative 1 squared plus 2 times negative 1 minus 4. I would have, let me fix, there we go. 1 minus 2 minus 4, so that's going to be negative 5. So, boom, done. No big. On the second one here, if I just directly substitute 2, I'm going to have 6 minus 2 is 4. The square root of 4 is 2. No big deal. But now, if you look at number 3 here, the limit as x approaches 0. If I directly substitute 0 in, I'm going to get 0 divided by 0. That's the indeterminate. I can't do that. Okay? But what if I were to factor that numerator? So if I were to factor out an x, leaving me with 4x minus 5 divided by x, cancel those x's, I'm left with 4x minus 5. And if I directly substitute, I'm left with negative 5. Boom. So we did it. Now, if you remember back to, say, Algebra 2, when you're first graphing rationals, that would be a hole in the graph, right? And if you were to plug back in, you would get your y-coordinate of that hole. So you would have a hole at 0, negative 5, right? And we saw that on our graphs when we were graphing. We'd be like, oh, hey, what's the limit from the left and from the right? Well, in this case, it'd be negative 5 from the left, negative 5 from the right. And there we go. We have a hole there, whatever the rest of the graph looks like. I don't know. But we'd have something like that graphically, okay? So it's always nice to connect things back to an earlier class, an earlier concept, and make those connections there. All right. Next one, I cannot just directly substitute here. So again, I'm going to have to factor and cancel. We'll see if that's possible. Oh my goodness. A lead coefficient in the numerator? The nerve. All right, so some of you are rainbow method folks. Some of you are just guess and check. I'll go through, let's see here. I'm going to go rogue. I'm going to go guess and check on this one because I'm just crazy like that. I know it's going to be 2x and x, right? That's the only way I'm going to get 2x squared. All right, and then let's see here. What multiplies to negative 7? Either 7 and 1, one of them being negative, right? And I want to add to 13, so I think if I put a plus 7 here and a negative 1 here, that's going to give me 14, negative 1, that gives me 13. I'm good. Also, you know, usually a nice little hint is that denominator there. If it's going to cancel. It doesn't always cancel. We're not always going to be able to factor and cancel. Sometimes it doesn't work out that way. All right, but in this case it does. Boom. And I'm left with 2x minus 1. So now I have the limit as x approaches negative 7 of that. And I can just directly substitute now. 2 times negative 7 minus 1. It's negative 14 minus 1 is negative 15. That is a terrible 15. Okay. That's a little better. I got a little too antsy, right? Okay, cool. So factor, cancel. Direct substitution doesn't work. Factor, cancel. Substitute again. Now, there are a few more, and actually, I'm going to let you guys, feel free to pause, jot these 4 steps down. They're nice, they're wonderful, they're fantastic. You can screenshot it, you know, and save it in your photos for later because you're totally going to look at them later. Or you could write it in your notebook where you have literally the rest of your math notes. I would suggest it. I'll let you pause. Okay, let us continue. So the next thing we have a situation where you factor but nothing cancels. That means you have like a vertical asymptote, right? There's usually a vertical asymptote then. If you have something left in your denominator that doesn't cancel, you don't get a hole in the graph, right? You have a vertical asymptote. Again, thinking back to rational functions back in the Algebra 2 days. So this often means that he's either approaching infinity, negative infinity, or just does not exist, okay? So if they're both approaching the same thing, you could say that it's approaching positive infinity, or that it's approaching negative infinity from the left and the right, or if they're approaching two different things, B does not exist, okay? And then if all else fails, we can always go back to our graphs and tables, right? That's a nice fallback. It's not always the quickest method, kind of like you could always use quadratic formula to solve a quadratic, but it's not always the quickest method, right? So we have other methods that are potentially faster, which are, for our limits, direct substitution, factor, and cancel. All right, so there's always multiple ways to solve a problem. Let's take a look at some piecewise functions and limits, shall we? So here I've got a piecewise function where it's defined as the square root of 11 minus x when x is less than negative 5, x plus 3 over 5 minus x squared when x is greater than or equal to negative 5. So what's the limit as x approaches negative 5 from the left? Well, the left side is when x is less than negative 5. So I'm going to be looking at this one here. So let's try a little direct substitution here and see if we can do that. If I plug in negative 5, I'm going to have 11 minus negative 5 is 16. The square root of 16 is 4. So direct substitution into that one worked. You could also look at it as I plug values in closer and closer and closer. Oops. Now, if I take a look at the next one here, we have the limit as x approaches negative 5 from the right. So now the right-hand side of the graph is going to look like this one here. All right, so let's see here. If I plug in negative 5, I'm going to get negative 2, and I'm going to jot down a little work here. Negative 2 divided by 5 minus, and if I plug that in, that's me 25. So I'll have negative 2 divided by negative 20, so that's 1/10. All right. So still nothing undefined, all good, all good. Now you might be looking at this and be like, hey man, I remember back in piecewise functions where I couldn't, if I was trying to evaluate at negative 5, I would be using only the bottom one there because that's when it equals negative 5. Well, you got to remember too, we're talking about limits here. We're not talking about what the exact value is at that point. We're just talking about what it's approaching. So that's why I did use the top part, the part where it's x is less than negative 5 for part A there, because that's when my values are less than negative 5 from the left side, okay? Now, the next part here, what's the limit as x approaches negative 5? Well, since these are approaching two different values, it does not exist. They have to be approaching the same value for that limit to exist. Okay, let's take a look at the next one. Shall we? I think we shall. Cool. All right. So the next one is the limit as as x approaches negative 1 of g of x. So when it approaches negative 1, I do need to check it from the left and from the right for it to exist. So let's check the first with the top one here. I'd have the square root of 10 minus negative 1 squared. This is the limit from the left side. So that's going to be 10 minus 1 is the square root of 9, which is 3. And then this one here, I'd have 26 minus 5 times negative 1 squared divided by 7. That's going to be 26 minus 5 is 21 divided by 7 is 3. So from the left and from the right, we are approaching 3. So the limit is 3. That's dope. All right. As it approaches E from the right. So I'm looking at this one here. I know it doesn't equal E in that, but I'm just looking at it as it approaches E, and that's where it's occurring, is that portion of this piecewise function. So we gotta recall some logs here. So I'd have, I'm gonna do some direct substitution. So natural log of E, I don't know why I put parentheses for that. E, I don't think that's really necessary, to the third. Now, if I remember my log properties, I could take this exponent, pop it out in front as a coefficient. So now I'm gonna have 3 times the natural log of E. And if I remember, natural log and E are inverses of each other. Just left with 3. That was cool. Look at that. Brings back so many different concepts, right? I got rationals I got to deal with. Now I have log properties. I mean, it's just a potpourri of math. All right, now for some one-sided limits here. Let's take a look. So we have the limit as x approaches 7 from the right. Of square root of x minus 7. Let's think about what that graph looks like for a sec here. So I think that's going to be very helpful. And I'm going to draw that down here. So x minus 7, that would be shifting 7 to the right. So 1, 2, 3, 4, 5, 6, 7. And I'm not going up at all, so it's just going to look like that, right? Up 1 over 1, up 1 over 3. Okay, so if I'm approaching 7 from the right, I'm talking about coming from, this side of the graph. I'm approaching what f of x value? I'm approaching 0. So this one would be 0. But as I approach it from the left, is there even a graph on the left? No. So that does not exist. So that would mean, and let me write this out, the limit as x approaches 7, just in general, of x minus 7, well, if it approaches 0 from one side but does not exist on the other, they have to agree, right? So this does not exist as well. Okay, cool. So even though that function is continuous where that function exists, the limit does not exist at that point, right? It exists from the right side, but not from the left side. Therefore, it doesn't exist altogether. Now let's take a look at this last one here. And we're going to pull out our calculator for this, okay? All right, so if I've got my TI-84 here, plus Silver Edition on my emulator, let's see. If I go to my y equals, and I'm gonna plug that in. I've already done that. Now you might be wondering, like, hey man, where did you get that absolute value? If I hit math right there, I arrow over to number, it's the first choice. Now my calculator is a little more old school on here, so it stays abs, but if you got some of the newer ones, it's gonna actually throw up the absolute value bars. Pretty cool. Okay. Like that, yeah, pretty cool because they put some basic, nice looking functionality into a calculator. Good job. TI, not the rapper, Texas Instruments. Ooh, voice crack. Okay, so I've got absolute value of x plus 4 divided by x plus 4. Now I'm going to hit zoom standard, zoom 6, just I don't remember what window I was in prior. Could have been something crazy. Okay, so if we look at this right here, what is going on? And I'm going to zoom in a little bit. Let's go over here and get to where, whoa, what the heck? Hold on. Zoom to, okay. I don't know why it jumped away there on me. But I want to get to the good stuff here, right? Right where the x equals negative 4 ish. And I want to see what's going on. So I'm going to zoom in there. So it looks like, okay, from the left, I'm on this stretch right here. So that means I'm approaching negative 1. Right? That's negative 1 right there. So I'm approaching negative 1. And I can even hit trace. And we can see that all the way along here, right, it's negative 1. It's just consistently negative 1. And if I were to plug numbers in, you would see that as well. But then all of a sudden, wait for it, whoop! Now it's a positive 1 as I come in from the right-hand side. So this limit is negative 1, but had we said the limit as x approaches negative 4 from the right of all this, I would be at positive 1. Therefore, the limit as x approaches negative 4 of all this does not exist because it's two separate things, right? It's called a jump discontinuity. You're welcome for that little future math. All right, that's it. That's the end. That's the last video. That's the last new content of this wonderful pandemic year. Now, I know if you're watching this in the future, you're like, wait, we're not done this year. We're barely getting started on limits. We're about to take it to the limit. We haven't taken it to the limit yet. Don't you worry. You'll have more videos. But this one is the end of 2020, 2021 PCH, Pre-Calc Honors School Year, so I wanted to make a big deal about it. You guys have a wonderful day. America Freedom, Rock and Roll Costco, Riverdog Jenny on the gram, and of course, YORO for mathematical accuracy, okay? None of those sig figs and things like that in science. This is math. We use all the numbers. All right, have a wonderful day. Deuces. Have a great summer. Hags, right? But if this is not this school year, this is like in the future, like 2022, you still have more math to do. Sorry.